Good morning, everybody. As Andrew said, I'm the banker on the six-head founder team of MFE. And for those of you who haven't been in touch with magnesium or as a critical raw material, it is a critical raw material and it's also a strategic raw material. It's been designated as such by the EU for several years now, and it's also an important metal in the transition to the energy transition. So, what is MFE? MFE is a project company. We're not producing anything as of today, but we're in the fairly advanced stages of planning for a magnesium production facility with a capacity of 15,000 tons per annum. And the facility will be located in Bosnia and Herzegovina. To be precise, in Canton 10, which is the western part of Bosnia and Herzegovina, bordering on Croatia. And if you look at the picture here, that's basically our future production site. And that's also where the raw material is located. It's dolomite, the white chalky stone that you can see here on the picture. The region is blessed with its geography and the weather. Two factors that make for an excellent location for green energy generation. And they are currently building a lot of wind farms there. They have 7 hydropower plants in Canton 10. And that's one of the factors that was very important for choosing that location as a future production location, because magnesium production is very energy intensive. So, as always, there's a problem, there's a solution. The problem is that magnesium is a key raw material also for alloying aluminum. Every can of Coke contains a few percent of magnesium, and it's the metal of choice in lightweight construction of, for example, electric vehicles, but also aircraft and the like. So it's really impossible to go without. And more recently, various scientists have discovered that it can function as a hydrogen storage medium. And Hydrexia in China, for example, they're already driving trucks based on that technology. So we in Europe, unfortunately, are totally reliant on Chinese imports. We have no own magnesium production. And the same actually accounts for the US. 90% or over 90% of the primary magnesium produced today is produced in China. And the problem is that the Chinese are expanding their use of magnesium. And we could easily run into a situation like we had 3 years ago, where suddenly the Chinese reduce exports, and in Europe, a couple of the technology value chains come to standstill. So the solution is reintroduce magnesium production to Europe, or find substitute materials. Both have their challenges. I'll talk about the first one. The second one, the problem is the scientists that I've spoken to at the various end users of magnesium, they say they try substitute materials every 2 years, and they just can't find anything that is or has similar characteristics or is of comparable cost. So we need a solution here in Europe, and the one that we are pursuing is the reintroduction of magnesium production to Europe, but in a cleaner, greener, and competitive manner than what we currently have in China and what we used to have here in Europe 20, 30 years ago. Our mission was motivated primarily by an investment that I made together with about 15 other individuals in a dolomite mining company in Bosnia and Herzegovina. And when we found that the material was of incredibly high quality, We had it analyzed for magnesium production a few years ago. And then this combined with the magnesium crisis sort of spurred us into action. And that's when we established MFE. The other factor that really convinced us to pursue this is the progress in MG production technology. Because over the last 10 years, there's been a lot happening, and I'll show you now what. So, the past was looking fairly grim, because, and I call it MG production 1.0, because 25 years ago, we had magnesium production here in Europe, but it was very energy intensive. It was a single product process. It involved expensive inputs. It was fairly dirty, with a lot of slag as solid waste, and overall had poor profitability. So we let the whole industry migrate to China. And that is the reason why, because the Chinese, they used the pigeon process. And this being a very electricity or energy intensive process, they had cheap energy, they had relatively inexpensive labor, they had the raw material, which is fairly common. Dolomite is a fairly common material, but it's you rarely find really high quality dolomite, and that of course helps the economics and the process. And in this process, as you can see down there, I mean, you get slag and you get only one product. So the estimated production cost, and that's an estimate from CM Group, who are the sort of leading researcher in the magnesium space, is $2,500 to $3,000 a ton for China, and in Europe it's slightly higher because of more expensive labor, more expensive energy, and therefore at the current magnesium price of about $2,500 a ton, it wouldn't be very viable to bring magnesium production back to Europe. So the question really is, I mean, why are we bothering? Why is MFE doing this? And there are two catalysts. I mean, one is technological progress, and the other one is the location and the quality of the raw material. The technological progress allows these days for a multi-product process with zero waste and very little CO2 emission. And the right location on the edges of the EU allows for relatively inexpensive energy, green energy, still good infrastructure, and we have the benefit of high quality raw material there in Bosnia and Herzegovina. So that makes for a clean, green, competitive and reliable process. Here's the process that we are going to use. It's called the althermic process. And the process is quite similar to what we've seen before, the pigeon process, but it has three important differences. I mean, one is it's run at a slightly lower temperature. It involves one more process step, which is the calcium-magnesium separation. And the third one is it's using aluminum scrap instead of ferrosilicon as a reductant. Now these three relatively small differences make for a very powerful impact, very powerful difference there. And that is, instead of one product, you suddenly have four sellable products. You have the magnesium after the refining at the bottom. You have dry ice at the top, which is the excess CO2 that you don't reuse in the process. You can siphon that off, and fortunately, where we are, there's a big market for dry ice for the fresh food industry. You get the PCC, the precipitated calcium carbonate, which is used by the plastics industry, for example. And you get aluminum magnesium spinel or aluminum oxide, which is a refractory material and also carries a significant value. So if you look at the green box on the right-hand side, 4 products instead of 1, 0 waste, because we're using green energy and we're distributing the CO2 footprint over 4 products, we suddenly get to a CO2 footprint for the magnesium of less than 1 ton per ton of magnesium. And that compares to about 20 to 25 tons of CO2 that you would emit for 1 ton of magnesium produced in the pigeon process. So it's a massive reduction. And the good news is the althermic process is an established process with a TRL level of 8 to 9. So it's a quantum leap, in our view, in magnesium production efficiency. And it's a great opportunity for Europe to reintroduce an efficient and environmentally friendly magnesium production. So before we get to the economics, let me say a few words about the althermic process. We had this, the process is originally a process developed by Alcoa in the 1960s, 70s. But as I said earlier, I mean, we sort of stopped magnesium production here in Europe. The Chinese used the pigeon process because they had plenty of cheap energy. But more recently, they've also become more environmentally conscious, and therefore they revisited some of the prior processes, and they have further developed and perfected the althermic process. And they have 4 active plants in China, and that's why we ran our industrial test on one of these plants in China, together with our technology partner LGE, which is part of Chalco, the national aluminum conglomerate. We had this test audited by DMT TÜV Nord, which is the German testing, inspection, and certification company. And we have now a test report which details exactly the quality of the products that we are getting, that we can achieve with our dolomite from Bosnia-Herzegovina, and also the exact plant configuration that we require. So, but before we get to the economics, let's take a look at the second catalyst, because that's also quite important. So here you can see on the left-hand side a picture of our open cast mine, where we currently mine the dolomite and sell it in small quantities to building materials industry. But it's a very large deposit, very homogeneous deposit of very high quality, over 100 million tons, and that would be sufficient to run our plant for well over 100 years. We could also ramp this plant up to 30 or even 50,000 tons per annum capacity, because in the vicinity there's enough green energy for that. The site that we own of 80,000 square meters is sufficiently large for that. And the infrastructure would also support that, because we're just 150 kilometers away from the Croatian port of Ploče, which is the gateway for shipping goods into and from the Balkan. And we're very close to the EU, and those of you who follow the sort of EU news, actually the EU opened accession talks with Bosnia-Herzegovina in March, and it's typically 2 to 3 years until such countries become full EU members. So here's the beef. Here's the economics. There are no scales for confidentiality reasons, but the size of the bars is for real, and will give you a pretty good idea of what the economics are going to look like. So let's first take a look on the left-hand side. Here the colors represent the different inputs. As you can see, the three main or the two main inputs in economic terms is the aluminum, the scrap, used for reducing for the reduction at the end of the process, and the other large cost item is electricity. We have started planning for an own wind park, and we get a lot of support there locally for that. And that would essentially halve our electricity cost. And then, and that means the total cost would shrink from about $4,000 to $3,000 a ton per 1 ton magnesium, but also 12 tons of byproducts. And if you then look on the right-hand side, I mean, here the colors represent the products produced, and the magnesium has an almost 50%, 45 to 50% share in terms of its value. And the other three products make up the rest. But as you can see, if you look at the first column on the right-hand side, the three byproducts have enough sales value to cover our cost, which gives us enormous pricing flexibility on the magnesium, which means we're not going to be a victim of Chinese price dumping activity or huge price volatility in the market, which has been historically a problem of the magnesium market. The second column on the right-hand side shows you what happened if we sold the magnesium to US buyers. In the US, the magnesium price is significantly higher than in Europe because they have 141% duties. Not clear how long they're going to have them, given that they have no own production anymore. But it currently makes for a very attractive price. So it's an option to increase profitability further. And what we've done on the far right-hand side is we've done a cost allocation where we basically took the far left-hand column and allocated these costs according to the product's sales value contribution. And there, if you look at the gray part of the column, the magnesium would be allocated a cost of about $2,500 per ton, which is very sustainable, and it's at a level where currently the Chinese can't even produce. So, as you can imagine, the three byproducts have been very much our focus, given their sales value contribution. And what I can say in summary is that they all have growing markets. They have very large markets. And we would have, I think if we went to 50,000 tons plus, we may find that we're a relatively large player in some of these byproducts. But until then, I mean, there's more demand than supply in these markets. These are some of the firms that we worked with. As you can see, the technology, we've been supported by DMT, but which is the TÜV Nord I mentioned earlier. But we also worked with the ETU, which is the Technical University of Istanbul, on validating all of the results that we got from the tests with our Chinese technology partners. On the supply chains, we worked with Fichtner Engineering, who are planning our wind park, do all the energy calculations. On the products and markets, we worked with CM Group and FMI. Locally, our whole planning and plant design has been done by ZGI. And we signed an LOI with Attila, which is a Turkish engineering firm. They built the last, they built the only European magnesium plant in Turkey for Esan, and operated it also. And they also volunteered to operate our plant. But we'll have to see. I mean, there's a good chance we'll team up with a large strategic who will have an interest in sort of cooperating or operating it solely. And we've done the LCA study with DLR in Stuttgart. They are the leading LCA provider for magnesium production. This is the core team. I'm being backed up here today by my colleague Albrecht von Kempis, who's sitting over there. As you can see, I'm the banker on the team, but we do actually have some industry specialists. Albrecht has a background in industrial minerals, and Ilhan is a mining engineer by education. He's I keep saying he's the only living individual in Europe who ever built a magnesium plant, because he was the one who built the plant for Esan in Turkey and operated it for several years. So we do have some very important know-how within the team. We have Jan, who's a serial project developer, and who's basically now residing in Bosnia-Herzegovina. Backed up by Jure, who is a local and who brought the opportunity to us in the first place. And then Richard is one of my oldest friends, and he's also a serial project developer. This is what the facility will look like when it goes into operation, hopefully in the second half of 2026. So the current status is we've done the industrial test. The results are more than encouraging. I mean, the quality of the products is fantastic, owed to the high quality of the raw material. We have acquired a suitable site. We are almost done with the local permitting process. We have 7 out of 8 permits received to date, and 1 we expect to receive in the next 4 weeks. As I mentioned earlier, we signed an LOI with an operator and general contractor. We have started a fundraising. The capex for this facility is around about $80 million. Why is the upper end at 200? Because, I mean, we could potentially look at integrating the mining operation, or we could add the wind park to it. But we expect half of it to be financed with venture debt from one of the PFIs, the public finance institutions like the KfW or the EBRD, that will make for even more attractive returns on the equity. Some investment highlights. As I said, I mean, we're almost ready to build, just 2 or 3 months away from that. We have more recently asked one of the top 4 auditing firms plus a technical consultant to conduct a full independent report on the project. That's something we need when we make use of government-sponsored loans, for example, or even equity out of one of the raw material funds. I mean, for example, the German raw material fund is now becoming live at the end of this month, and we'll certainly file an application there. We have very strong underlying markets. we had so many inquiries for offtake agreements. I couldn't really deal with them, and then we sort of stopped discussions for now. But the fact is, everybody who's using magnesium is desperately looking to diversify their supply, because right now, I mean, they can only buy in China. Given the CRM nature of magnesium, we get strong support from European politics out of Brussels. And as you spotted earlier, I mean, the great cost-income relationship makes for very attractive financial returns.